Okay, so today we are going to be doing a Module 10 Problem 5, and this question asked, a roasted chicken is served at a dinner party. It starts to cool according to Newton's law of cooling. Temperature T is given by the equation T of T is equal to 80 plus 222 to the e raised to negative 0.04 multiplied by t time. So we're asked to do three things. First thing is find the initial temperature. Then we're going to find the temperature after 9 minutes, and then we're going to find how long it takes to get to 105 degrees according to Newton's law of cooling. So to start this out, we're going to do number A. So what you want to do this is initial temperature is going to be times 0. Think about it in a graph on a scale. If you have 0 at the left side, it's going to move forward in time. So what you do is you want to plug in 0 for t. So what you're going to do is you're going to plug in 0 for t. So you have negative 0.04. Let's do this way. So you're going to have t of t is equal to 80 plus 222 e to the negative 0.04 to the 0. This is going to cancel out and give you 0, because negative anything times 0 is going to give you a 0. E to anything is going to give you 1 as a whole entity. Then you're going to multiply 222 by 1, which, as many of you know, is going to be 222 itself. And then you're going to add 80, which is going to give you 302 degrees. So that is the initial temperature according to Newton's law of cooling. The next we're going to do is B. This, what you're going to do, instead of plugging in 0, you're going to plug in 9, because they're asking for the temperature after 9 minutes. So what you want to do is take the equation T, same equation as above, so the first step in here, just like we did up there, you're going to take this, negative 0.04, multiply it by 9. That's going to give you negative 0.36. Next, you're going to take e and raise it to the negative 0.36. That is going to give you 0.69. Next, the step is you want to multiply negative 0.69 by 222, which is going to give you 154.88, and then you're going to add 80, and that's going to give you 234.88. That's going to be the temperature after 9 minutes. Then we will go right down here. We'll do how long to 105 degrees. To solve this, instead of solving for time, you're going to be solving for initial temperature. So what you want to do is, they're giving you that initial temperature. So they're saying at 105 degrees, what is the time it takes to get down to 105 degrees? So you have 100, let's draw a little thing there. So you have 80 plus 222 e negative 0.04, and then you have t. So what you want to do to get rid of this first, you want to subtract 80, just like any algebraic problem, and that's going to give you 25. It's going to give you 25 equals 222 e to the negative 0.04 t. Next, what you want to do is you want to divide by 222, which is going to give you 0.1126, which is going to equal e to the negative 0.04 t. Then what you're going to do to get rid of this e, and the opposite of e is going to be the natural log, which is ln. You're going to take the natural log of 0.1126, which is going to be the same thing as taking the natural log of e of negative 0.04 t. And these will cancel out, the natural log and the e, which leaves you with only this on that side. So what you want to do now is you want to take the natural log of 0.1126, which is going to be negative 2 -0.803. No, 18. I'm sorry. It's going to be -2.183 is going to equal -0.04 t. The next step is to divide -0.04 from the t into the -2.183, which is going to give you 54.59. And if you round that up to 55 minutes, that's going to give you the time it takes to reach 105 degrees. I hope that helped, and yeah.